populations are dynamic. There's tons of variables, there's tons of factors that influence whether a population grows exponentially, grows flatline, or decreases. And that's true of plants, it's true of animals, it's true of fungi and everything else, and it's true of us. So we're going to start population dynamics here. However, there's going to be sort of this great shift between wildlife population dynamics and human population dynamics. Wildlife populations don't deal with things like economy, education, religion, culture, various historical events like wars. Okay, so wildlife populations are regulated by different factors than human populations. Furthermore, that human populations don't have other external factors like poaching or habitat loss, things like that. So we're going to start here with just some very basic terminology and basic mindset of the things that I want you to think about when you think about whether or not a population is going to become threatened and endangered, or that would be threatened or endangered, or rise exponentially like rats. Now we're going to talk about wildlife here, but plants is the same way. So one of the things that we'll talk about wildlife here in Texas. We'll start with reproductive potential. And that is, and I'm not gonna write this out. You guys don't want to watch me sit here and write out a definition. Besides, you're all on a computer. You're Googling away. Definition, dictionary.com, reproductive potential will take you seconds. But I'm going to give you some examples from right here in Texas, right here where we live in the Post Oak Savannah Eco region. Wild hogs versus white-tailed deer. Wild hogs may have litters of 9, and they may have litters of 9 2 or 3 times a year per female. White-tailed deer per female in a great year. Loads of water, loads of fruits and nuts and acorns and everything, loads of vegetation for them to eat, perfect resource availability, and they're going to have 2. They might have twins in a year. And that's best case scenario, okay? Look at the reproductive potential difference. So these they're exotic, but this is why they're invasive. One of several reasons is because they have a much greater reproductive potential. Right here in Texas and all across the South, there's another invasive exotic called the snakehead, northern snakehead, Channa argus. And it is very, very similar to another species called the bowfin. It has several names throughout the South. And you can pause this video and look up the 2 fish, and you'll see that they look very similar. They live in very similar habitats and things like that. The northern snakehead is from Europe. That's where it evolved, and it has become exotic and invasive exotic over here. That fish per female may have twice as many eggs as our native bowfin do, twice as many. And so there's a reproductive potential off the bat, just from the get-go, before we talk about resource availability and habitat use and everything else. Just how many eggs do they lay? And Channa argus, the northern snakehead, has already won the game, simply just based on the number of eggs. Resource availability, or what we call allocation. And again, I'm not going to bore you writing out, watch my back as I write out definitions. I'm just going to give you some examples. So resource availability, when we talk about resources, what does that even mean? So your basic resources: food, water, shelter. Actually, I'm going to use a different marker. You know how it is, got to have a fresh marker. So availability or allocation, those are really two different concepts. Availability is just, is it there at all? Are the resources even there? And allocation has to do with what else is using those resources. Okay, so whether or not there's a whole lot, there's almost too much to define here, particularly with the space that I have. But there can be decreases in food. And this is part of the problem with habitat loss. If you live in the rainforest and you eat the fruits that fall from the trees and then loggers come through and cut all the trees down, well, I'm still right here. I'm still right here in this habitat. However, my food resources are now gone. It rains all the time. I've got loads of water. But if I don't have any food, well, then my population doesn't grow. And it decreases. We become threatened and endangered. Does that make sense? And so that's true of everything here. Let's say that you like shelter. Oh, we'll talk about some species here in Texas. If you're a cavity nesting bird, trying to think of a few off the top of my head, maybe the American kestrel. And you can look that up. It's a gorgeous little bird. Or like merlins and there's loads of others, owls, that sort of thing. If you're a cavity nesting bird and you live in the southern pine forest, and the loggers come through, cut all the trees down, but then they plant new trees, okay? And there's loads of trees, thousands of trees. You're right there in East Texas. Rain's the same, right? There's mice and rats, there's food for you, right? However, if there are no old growth trees that have hollowed out centers, there's no cavities in those trees, well then you don't have a way to make nests. You don't have a way to live out your life cycle. So the shelter has decreased, even though these other resources are still available. Let's talk about allocation. Let's say that you're a deer and you're really hoping on all the acorns that fall on the ground. And you really need that to make it through the winter. However, there's been an explosion in the rat population. The rats are cleaning house. They're cleaning up acorns left and right. Wild hog herds have moved in. They're nomadic. And so several herds have moved in and they're eating like crazy. They've got piglets everywhere and little piglets are eating up all the acorns. Well, whether or not those resources, they're there. The food's there. The water's there. The shelter's there. But those resources are being reallocated to other populations and not to yours. So your population is going to start to decrease, flatline and decrease, and those other populations of those invasive exotics are going to start to increase. One of the other major factors that affects how organisms' population goes up or down, or whether or not they will go up or down, is called zone of tolerance. Zone of tolerance has to do with the abiotic factors. Okay, this is not the interaction between invasive exotics and stuff like that. Zone of tolerance has to do with, sorry, I'm in the way. Zone of tolerance has to do with the range of abiotic factors that an organism can deal with in its environment. And I'll give you some examples just in your own life, okay? So, like in your house, you try to keep the temperature within, a pretty close range. So, let's say you live in Alaska and it's -30 outside. Well, that would be too cold in your house, right? You wouldn't want it to be -30 in your house. So that's outside your zone of tolerance, right? You can't be exposed to that for very long. Maybe for a few minutes you can handle -30. But if you're out of -30 for a long time, then you'll die. Same thing with, like, let's say the heat in my car. Okay, it is, I'm sorry, low battery. Anyway, the heat in my car. So when I go out to my truck and I open the car door, it's going to be approximately 140, 150 degrees inside that car. I can take it for a few minutes while the truck cools off, but you can't handle 150 degrees for very long because you'll die. Okay, it's outside your zone of tolerance. Now, it doesn't matter who else is in the truck with me or what else is going on in society in Alaska or whatever, but if I'm exposed to that abiotic condition for too long, that's it. I'll die because it's outside my zone of tolerance. Now, organisms, let me pause here and write that. So this is a range of abiotic factors that an organism may or may not be able to handle. Good. Now, like, say right here in Texas, and you've seen a lot of the videos from around the neighborhood that I live in and the kind of area I live in, and I'll try to show you a bullhead catfish if I can catch one in a trap. Now, bullhead catfish can live in your fish tank. I raised one when I was a kid. I grew up right over off of Jackson Road over there, and I raised a bullhead catfish in my tropical fish tank, swimming around, and eventually, they're not good pets. Don't do that because it ate all my fish. But anyway, one of the neat things about bullhead is they can handle extremely low oxygen levels. So when I released the fish into the wild, it is a native fish here, and I got it out of the wild. I caught it in a creek where they're native, and I released it into Lake Louisville, and it's probably dead. But anyway, I could have released that fish into water that was extremely low oxygen, like in a swamp, for instance, or a stagnant pond, like you saw in some of my other videos where I talked about turbidity and things like that, because it can handle extremely low oxygen. If I did the exact same thing with a similar catfish of a different species, like a channel catfish, then that fish would die because that super low oxygen condition is outside of its zone of tolerance. If I did it with a blue catfish, it would certainly die. If I did it with a largemouth bass or anything else, it would certainly die. So that abiotic range of oxygen level, right, has affected what organisms' populations could increase and what populations are going to decrease or even crash dramatically, and those organisms are going to be extinct from that habitat or are going to be gone from that habitat altogether. And so this is a biological issue. That's just how many eggs they're going to lay, how many babies they're going to have, right? And then resource availability, that can be everything from habitat destruction, climate change. It can be the presence of invasive exotics. And zone of tolerance, that is just physical state, physical issues, abiotic factors that the organism may be able to deal with that others can't. Or it may be abiotic factors that it can't deal with that everything else can. So, like of those two, let's talk fish for a second again. I've already mentioned Channa argus, the northern snakehead. It can handle very cold climates in Russia and things like that, and it can also handle the nice, sweaty, warm climates of Florida. And it can handle that whole range in between. So they become a pretty serious invasive exotic because it can handle a lot of things. It can even breathe air. It can handle extremely low oxygen levels. So you almost can't kill them. They can even live outside of water for like 3 days. So it's amazing how little oxygen they can have and survive. Now the way opposite end of that is something like a salmon, that if the water is even slightly turbid or if the water's slow at all, if there's any decrease in oxygen for any reason, they're out. If the water warms up for any reason, even a little bit, you would touch it and swear that it's cold. But if you look into some reading about the decrease in salmon populations in Alaska, you'll see that they can't handle any change in that water quality. If it just a few degrees warmer, they're out. If it's turbid, they're out. Low oxygen, they're out. And there are invasive exotics that can handle those changes. And that's part of the reasons that you see in an ecosystem, some populations starting to creep up or explode, and some populations decrease a little bit or crash altogether.